In this presentation, we are going to discuss about process scheduling in operating system. The outlines are process concept, process scheduling, operations on process, inter-process communications. In the process scheduling, the process scheduler is used. It does a selects. It is organizer. Okay. So the process scheduler select among available process for the next executions on the CPU core. Its goal is maximize CPU use, quickly switch process onto the CPU core, and also maintain the scheduling queues of process. There are two queues, ready and wait queues. So in this ready queue, set of all process residing in main memory, ready and waiting to execute. In the wait queue, set of process waiting for the event of IO input and output. The process migrate among the various queues. So ready and wait queues structure. Here in this ready queue, the process or wait to executes. So in this executions, the registers and the contents variables are stored separately. The representations of process scheduling. The process to be scheduled based on the request. Okay, so in this priority scheduling, which process to be first sent a request that is processed. CPU switch process. So here the process to be switched from one process to another process by the context switching. When the CPU switches to another process, the system call is used. Okay, so it is an interrupt for the executions of one process. So the systems must save the current state of the old process and load the saved state for the new process. So it is in context switching. The context of a process represented in the PCP. So the context switching time is a pure overhead. The systems does no useful work while switching. The more complex the OS and PCB, the longer the context switch. Time dependent on hardware support. Some hardware provides multiple set of registers per CPU. So the multiple contexts loaded at once. So the multitasking in mobile systems. Some mobile systems allow only one process to run, others suspended due to screen real estate. User interface limit IOs provide for a single foreground process controlled by a user interface and multiple background process in memory running but not on a display and with limits. The limits include single short task receiving notifications of events, specify long running tasks like audio playback. Android run foreground and background with fewer limits. So the background process uses a service to perform the task. The service can keep running even if background process is suspended. The service has no user interface, small memory use. The operations on process. The system must provide the mechanisms for process creations, process terminations. The process creation. In the process terminations, process executes the last statement and then asks the operating systems to delete it using an exist system call. The returns status data from child to parent and process resources are deallocated by the operating system. So inter-process communications. The process within a systems may be independent or cooperating. So the cooperating process can affect or be affected by the other process, including sharing data. So reasons for cooperating process: information sharing, computation speed up, modularity, convenience. So the cooperating process need Inter-process communications. So the two models of inter-process communication, shared memory and message passing. So the communications models for the shared memory and the message passing. So here the process A and process B is executed. It can't use the shared memory. So using the kernel, and in the message passing some kinds of message is in the queue that is to be passed from both the A and the B. Producer consumer problem. Here the producer process produces information that is consumed by the consumer process. Two variations. Unbounded buffer places on practical limits on the size of the buffer. That's the producer never waits. Consumer waits if there is a no buffer or to consume. The bounded buffer assumes that there is a fixed buffer size. The producers must wait if all buffers are full. The consumers wait if there is a no buffer to consume. So in this IPC message passing, the process communicate with each other without resorting to shared variable. So this IPC facility provide two operations, send message and receive message. The message size is either fixed or the variable. So in this, if the process P and Q within the communications, they need to establish a communications link between them. So exchange the message via sent or receives. So before the message sending or receiving, it must be establish a communications link between the sender and the receiver. Okay, if the process P is in sender and the process Q is in receiver. In this, it has some implementations issues. How are links established, and can a link be associated with more than two processes? How many links can there be between every pair of communication process? And what is the capacity of link? Is the size of message that the link can accommodate fixed or variable? Is the link unidirectional or bidirectional? So in this implementations, it has two forms, physical and logical. In this physical is used for the shared memory hardware buses network. In the logical, direct or indirect synchronizations or asynchronizations, automatic or explicit buffering. So in this direct communications, the process must name each other explicitly. So in the sending and receiving process, it specific name explicitly. So in this sending, send a message to the process P. So the name of the receivers to be specified explicitly. The properties of communications link are established automatically. A link is associated with exactly one pair of communicating process. Between each pair there exists exactly one link. The link may be unidirectional but is usually bidirectional. Indirected communications. The messages are directed and received from mailboxes. So each mailbox has a unique ID. So the process can communicate only if they share a mailbox. So the properties of this type of communications link is the link established only if the process share a common mailbox. A link may be associated with many processes. Each pair of processes may share several communications links. Link may be unidirectional or the bidirectional. In the synchronizations, blocking is considered synchronous. So blocking sent and blocking receive is a process. Then in the non-blocking is considered as asynchronization. So it makes a non-blocking send and non-blocking receive. Then the buffering, queue of message attached to the link. The implementations in one of three ways. zero capacity, bounded capacity, unbounded capacity. So in the next process is in pipe. So it has to maintain the data and also communicated using the ordinary pipe and the named pipe. The communications in the client server systems by using the sockets or remote procedure calls. So sockets is defined as an endpoints of communications. So concatenations of the IP address and port. So the socket is created from the IP address and its communications consist between a pair of sockets. All part of the sockets is IP address and its port value for the particular network. Then the socket communications. Thank you.